This is a story about our home. It's really big. It's also really old. And it's filled with things that are just mind-bogglingly cool. It's also kind of dangerous. But in the end, it's also where we came from, who we are and what we'll become. I'm here to tell you the story of our universe. And if that sounds like a big deal, well, it is. So let's do this thing. Let's start at the beginning. Actually, let's go before the beginning. Let's go back to 13.8 billion years ago. Back then, time didn't exist, space didn't exist, and physics as we knew it didn't exist either. All the energy of the universe was squished together in one place. Mathematicians call this point a singularity. We don't really know what it would have looked like or whether anything even looked like anything. What we do know is that all the energy that was inside that singularity exploded outward in every direction faster than light in a cataclysmic event we call the Big Bang. In a fraction of a second, space and time themselves were born. And this explosion wasn't just some little pop. This was a cosmic firecracker. Every single atom in your body, every star, every planet, every bit of everything you see around you was flung out from that initial explosion. Right now, the universe is still expanding, still flying outward away from that starting point. As stuff spread out through the newly created space, it began to cool. As it cooled, energy started to condense into particles, mostly hydrogen and helium, the simplest forms of matter. Within minutes, the universe went from unimaginably hot and dense to relatively tame, at least by cosmic standards. Now that matter existed, gravity could start to take hold. Over hundreds of millions of years, gravity pulled matter together into enormous structures, the first galaxies. Meanwhile, the rest of the universe kept expanding. Eventually, these clumps of matter got big enough for gravity to start pulling them into spinning disks. And that process of spinning and crashing together eventually formed our galaxy, the Milky Way. But how did those stars get there? You can't make a galaxy without stars, but they don't just spontaneously generate. They form in places called nebulae, which are giant clouds of gas and dust floating in space. These stellar nurseries are usually found in the spiral arms of galaxies where conditions are perfect for creating new stars. Here's a close-up view of the famous Orion Nebula. Imagine a much higher resolution version of this. Now imagine that image filling your entire field of view. That's how large a nebula is. If you zoom in on the heart of this image, you can see tiny dots, pinpricks of light amidst the dust. Each of those dots is a baby star. Like children, they're being nourished by the giant cloud they're born out of. But, unlike children, they're burning through their food supply in a matter of millions of years. As each protostar fuses its mass, it pulls in more and more material until it reaches a critical threshold. At that point, the pressure and heat at the core becomes great enough to ignite nuclear fusion, the process that powers all stars. Once that happens, a star is born and will shine for millions or even billions of years. Our sun is about halfway through its life cycle. The amount of time a star spends living is closely related to its size. Smaller stars like our sun fuse hydrogen into helium at a slow and steady pace. Massive stars, on the other hand, burn their fuel incredibly quickly and die young. Here's a timeline showing the life of a small star versus a massive star. These colored dots represent various stages in the star's evolution. The horizontal axis represents time on a logarithmic scale. Notice how huge the gap is between a small star's stage and a massive star's stage. This is because a massive star goes through its fuel so quickly. To understand what's going on here, check out this HR diagram. On the horizontal axis is a measure of a star's temperature. Hotter stars are on the left, and cooler stars are on the right. On the vertical axis is a measure of a star's luminosity, or brightness. Hotter, brighter stars are at the top and cooler, dimmer stars are at the bottom. Stars naturally fall along a diagonal line when they first ignite. This is called the main sequence. A star's position on this line indicates how long it will live. Stars that are bigger and hotter fuse their fuel faster and die sooner. Stars that are smaller and cooler fuse their fuel slower and live longer. Our sun is about halfway through its life right now, which means it has roughly another 5 billion years to go before it exhausts its supply of hydrogen. At that point, the star will expand dramatically, engulfing inner planets, including Earth. Don't worry though, humanity has plenty of time to plan ahead. What happens after a star exhausts its supply of hydrogen depends on its mass. If the star is small, it will simply cool off and fade away into the darkness as a white dwarf. If it's massive, its core will collapse, triggering a tremendous explosion called a supernova. During a supernova, the star blows itself apart and scatters its guts across the galaxy. These guts contain the heaviest elements that are forged in a star, elements like carbon, oxygen, and iron, the very ingredients of life. These elements are scattered across the galaxy, creating more nebulae, which will eventually become the next generation of stars. Some of the iron in your blood, the carbon in your cells, the calcium in your bones, all of it was forged in the heart of a star that died billions of years ago. As for the star's core, what happens to that depends on its mass. If the core is small, it'll collapse to such a small radius that gravity will pull everything toward the center. Not even light can escape collapsing gravity, and a neutron star is born. Here's an artist's conception of one. Look how dense it is. Now imagine taking a teaspoon of matter and compressing it down to the size of an ant. That's how dense a neutron star is. Neutron stars are incredibly cool and fascinating objects, but they're pretty small. Usually only a few kilometers across. If the core is big enough, though, it'll continue to collapse past the neutron star phase. Gravity will keep pulling things toward the center until not even time can escape collapsing gravity. And at that point, nothing, not even us, can know what's happening. A black hole is born. Everything that crosses the black hole's boundary, called the event horizon, is pulled inexorably toward the center. Nothing escapes, not even light. All that remains is an empty shell, an apparent absence of anything at all. This region of empty space is sometimes called the abyss. But what lies beyond the abyss? We don't know. Because no information can escape a black hole, it's impossible for us to know what happens inside. It's a place where physics, as we currently understand it, breaks down. Zoom out once more, and put our sun and our galaxy in context. Our solar system is a small part of a flat disk of stars called the Milky Way. There are hundreds of billions of stars in our galaxy. Well, actually, we don't know exactly how many. This is what we call the observable universe, everything we can see. Beyond that, the universe keeps going and going forever. Let's zoom out even further. Here's our galactic home nestled within the local group. In total, there are over 50 known galaxies in this group. These galaxies are held together in a vast network, the cosmic web. You started out as a cloud of gas, a collapsed cloud of dust and gas, a protostar, a newborn star. Maybe you became a red giant, or maybe you went supernova. Maybe you collapsed into a white dwarf or a neutron star or a black hole. Whatever you became, wherever you are, it's all made of the same stuff as everything else in the universe. We may be made of stardust, but we are also stardust. We are literally part of the universe. We may seem small and insignificant, but we are also connected to everything and everyone in the cosmos. Okay, so that's our universe. See, that wasn't so hard. It's not every day that we get a chance to zoom out and see our place in the grand scheme of things. I hope this video helps you feel connected to something bigger than yourself. Something eternal and magnificent. And if you ever feel lost or alone or insignificant, just remember, you're made of the same stuff as stars.